we're just going to be introducing ionic naming. So we're done with molecular naming. And for ionic naming, now we're talking about metals and nonmetals. But before we do that and do any of the naming, we first need to just talk about what is called the oxidation number, or the oxidation state, okay, on the periodic table. So, for example, let's take a look at zinc, where it tells us what it is on the key. This number 2 says it's called what? The oxidation state. And if there's more than one number, and one of them is bolded, like you can see on some of these where one of them may be bolded, what does the bolded one mean? It's the one that's most stable. I want to see if you can figure out what this number means, okay? So, let's take a look and see if we can figure out a trend here. So, hydrogen, under the alkali metals here, hydrogen we said kind of does a little bit of acting like a metal and acting like a nonmetal, so it can do a little bit of both. So let's take a look at lithium all the way down to francium. What's lithium's oxidation state? 1. And then you keep on going down. Sodium is 1. Keep on going. 1, 1, 1, 1. Now take a look at the alkaline earth metals. Beryllium's is 2. What about magnesium? 2. Calcium, strontium, and barium. What about scandium? 3. Yttrium, lanthanum. Those are 3s. Now, once you get to titanium, something funny happens. But what's the bolded one on titanium? 4. Zirconium. 4. Hafnium. 4. Vanadium's bolded one is also a 5, 5, 5. Then things get really different as we move into the transition metals. Okay? So we're seeing that first. We're seeing that these are all 1, 2, 3, 4. Let's take a look at the nonmetals. What's wrong with the noble gases? They don't have one. So whatever this number is, this what we're calling oxidation state, the noble gases don't have one until we get down to krypton. And I'm going to tell you that the 0 is the bolded one. And the other numbers were actually done in lab, and it was something temporary. That's all I'm going to tell you, and I'm going to see if you can figure out what this number means to us. Okay? Look at fluorine. Fluorine says -1. Under that, there are a bunch of positive numbers, but what's the only negative number? -1. There are a bunch of positive numbers on bromine. What's the only negative? 1. How about iodine? -1. And how about acetine? -1. Now, once you get under the staircase, we had said that we're going to pretty much treat the metalloids, if they're to the right, as nonmetals, and if they're to the left, as metals. Okay? So once you pass the staircase line, then things definitely get different. So this is only going to apply to the nonmetals above the staircase, or to the right of the staircase. Let's do the next one. Oxygen says -2 or -1. But we're actually going to take this to be a -2. It's only -1 in peroxides, so we're going to say -2. Okay? What about sulfur? What's the only negative number? -2, just like oxygen. What about selenium? -2. And what about tellurium? -2. Nitrogen? -3. -3, -3. Carbon, -4. These, first of all, I do want you to write on your periodic table. I want you to write a 0 above helium. I want you to write a -1 above fluorine, a -2 above oxygen, a -3 above the nitrogen, and a -4 above the carbon. Just really small, doesn't have to be big. You can do it in pencil, okay? So just write those numbers in on there. What do you think this number is telling us, this what they're calling the oxidation state? These were positives, +1, +2, +3. These are 0, -1, -2, -3. Charge. Awesome. It's actually the charge. What does that mean? Charge. What is that telling us then?
Like how many electrons to add or subtract.
Perfect. Awesome. This is telling us how many electrons are either being lost or gained. If it's positive, do you remember? If it's positive, what happened to the electrons? They were lost. Metals will only lose electrons. If you look across here, you're only going to see positive numbers on the metals. Because metals won't gain electrons, they'll only lose electrons. Let's go to the nonmetals. Now, nonmetals can be different, but why do the noble gases have 0 charge?
Because they don't lose them.
Yeah, take a guess.
Okay. When you get to the end, they're full.
They're full. Full what? Full energy level. The entire level is then filled with electrons, and that makes them more stable. Having these as P6s, that means that their S is filled and their P is filled for that particular energy level. That actually makes the noble gases stable. Every other element on the periodic table wants to be just like the noble gases. The noble gases are like, I don't want your electron. I'm not going to give you an electron. I'm happy the way I am. I'm a king. I'm a queen. I'm noble. So those are the noble gases, okay? Now the rest of them, why do you think then that fluorine has a -1 charge? What does negative mean? You add one. And if you add one to fluorines, instead of having 9 protons and 9 electrons, if it's neutral, it would have 10. Oxygen. Oxygen's charge is -2. Oxygen has 8. -2 means add 2, so now it has 10, like neon. Let's come back over here. Sodium has 11. If it loses 1, it will have 10, like neon. What about strontium? 38. Plus 2 means what?
36.
Take away 2, that would be 36, like krypton. Let's come into here on something like zirconium that has a +4. What's 40 but then -4, remember? 36, like krypton. What's going to happen is these will all become charged. Now, I want you to understand that in nature, they're neutral, okay? They have 0 charge. If you had a piece of gold, a piece of silver, a piece of sodium, it has no charge. Meaning, what 2 things are equal in the atom? Protons and electrons. Good. Positives and negatives are equal to each other. When they bond, it's only when they bond that they end up either losing or gaining electrons, and they will lose and gain electrons to become more stable, like the noble gases. Okay? So that's basically how this works, which is really cool. And so what we're going to talk about is naming. Only now we're just going to say what are the oxidation numbers of these metals or these nonmetals. Okay? So back to the notes on here. We already talked about cations and anions, but metals will lose electrons, and if they lose, it makes their charge what? Positive. Nonmetals, on the other hand, will gain electrons, and so they will become charged negative. Now, you may have seen some positive charges on the nonmetals. We're not going to talk about those at this time. The only thing I'm going to tell you is, because we're doing metals with nonmetals, if the metals are losing, the nonmetals have to be gaining. Perfect. Okay? So we have to have opposites on there. So we always said the cats are cute and pleasant, positive, onions make you cry, those are going to be negative. When atoms are alone in nature, they have the same number of protons as electrons, so we call them neutral. Very good. Call them neutral. When the atoms bond, they will either lose or gain, or they will share their electrons. The molecular compounds will generally share, but then ionics are going to lose and gain. We're going to do Club Chem in just a little bit. Let's answer the questions underneath first. So we're going to start at the back. So the first one is F. What I want you to do is I want you to find fluorine on your periodic table, and what charge did we give it, did we write on the top of that group or that family? -1. Perfect. All right, next person. So what do you have for Cl? What does it say above the group Cl?
-1.
Awesome. Br.
-1.
And carbon. -4. Even though there's more than one number on there, we are going to take all of these to just be the fixed number that we wrote on top. So 0, -1, -2, -3, and -4 is what you're going to use on there. Next part, it's either asking us whether the charge is fixed or variable. So I want you to draw 2 boxes. In this first box, I want you to just put an X as if it were like on the periodic table, one of the symbols. And right above it, we'll do an oxidation number. Let's just say that the number above it is a 2. If there's only one number above it, we're going to call that fixed. Then I'm going to have you draw another box. And in this box, you're also going to put an X in there. But now I want you to write a 2, 3. And then this, if there's more than one number, we're going to say that it's variable. So, some elements will only bond by losing a certain number of electrons or gaining a certain number of electrons, okay? Others, it depends on the situation. Sometimes some elements can lose different numbers. They can either lose 2 electrons or 3 electrons. But if it's fixed, it will only bond if it loses 2 electrons, for example, okay? So that's what that number is telling us. So, next person, as we come up here. So, calcium, find calcium on the periodic table. And what is the little number written above calcium, please? 2. +2. You can write it as +2 or 2, it's the same. Would you call this fixed or variable based on what we said? Fixed. Awesome. Okay, next person. Potassium.
+1.
+1, or a plus is fine, or a 1 is fine. They're all the same. Fixed or variable.
Fixed.
Nice. Ag, so silver.
+1.
+1,
Fixed.
fixed or variable.
Fixed.
Very good. Zinc.
+2.
+2, fixed or variable.
Fixed.
Very good. Very nice. Perfect. The next one, Mn.
+2, +3, +4, +6, +7.
Perfect.
Variable.
Variable. Very good. Platinum.
+4, +2, variable.
Very good.
3 and 1. Variable.
3, 1, variable. Good. And hafnium.
+4 and fixed.
Very good. Awesome. Okay, and that's basically it for the oxidation states. And we'll come back and talk about how to name them all in the next